In this video, we'll be learning about extrema of functions, which are the maximums and minimums of a function. Now, there are two types of extrema, relative extrema and absolute extrema. We'll start by looking at relative extrema. Sometimes you'll also hear these referred to as local extrema, or local maximums and minimums. We say that a function has a relative or local maximum at a point a, f of a if f of a is the largest output or y value of all points nearby. Similarly, we say that a function has a relative minimum or local minimum at a point a, f of a if f of a is the smallest output or y value of all points nearby. Let's take a look at an example of a graph of a function and try to determine where its relative extrema are. For our graph here, let's look at a few points and decide whether or not they are relative maximums or minimums. Let's start with looking at this point. Now, if we want to decide whether this point here is a relative maximum or a minimum, what we need to do is compare this point with some of its nearby points. So let me highlight some points that are near it on my graph. So first, let's ask ourselves, is that blue point a relative maximum or a local maximum? Well, what we need to do is look at nearby points and ask ourselves, does our blue point have the largest output or y value here? So looking at our highlighted region, well, the answer would be no, because we can find a point that has a larger y value. For example, this point here in my highlighted region has a larger y value. For that reason, we have to conclude that our blue point is not a relative maximum. Now we can also ask, is that blue point a relative minimum or local minimum? In order to determine that, again, we need to look at nearby points and see if it has the smallest y value. So looking at our highlighted region here, does my blue point have the smallest y value? And the answer here would be no, because this point in red that's in my highlighted region has a smaller y value. So it turns out that my blue point is not a relative minimum either. Let's now consider a different point. Let's take this point here. If I want to determine whether this point is a relative maximum or minimum, I want to compare it with some nearby points. So let me highlight some points that are nearby that point. So first, let's ask, is our green point here a relative maximum or a local maximum? Does it have the largest y value when we compare it to its nearby points? Well, just looking at this highlighted region, our point here does have the largest y value because it's the highest point when I'm just looking at this highlighted region. For that reason, we say that this point is a relative maximum or a local maximum. Now, I want to stress the adjective relative or local because we're only comparing this point with points that are near it. We're not looking for the highest point in the entire graph because, well, the highest point in the entire graph would be right here. But this, when we compare it with other points that are near it, is the highest point. That's why it's a relative maximum or a local maximum. Now, for our green point here, we can also ask ourselves, is it a relative minimum? So, in order to determine this, we want to look at the nearby points or this highlighted region and ask, does it have the smallest y value? Well, the answer would be no, because we can find a nearby point with a smaller y value. For example, this red point here has a smaller y value when we compare it to the green point, and so our green point is not a relative minimum. Now, another point that's a relative maximum would be this point right here. When we compare this point with some of its nearby points, we see that this green point has the highest y value in this highlighted region. That's why it is also a relative maximum. Now, you might ask yourselves, is this left end point here also a relative maximum? While it does fit the description that we've mentioned in the beginning, This is not considered a relative maximum. It is a convention that we go by that endpoints of a function are not considered for relative extrema. So our two endpoints, the endpoint on the left and the endpoint on the right, will never be considered as a relative maximum or minimum. Let's now consider another point on our graph. Let's take this point here. Let's determine if this point is a relative maximum or a relative minimum. In order to do that, we need to first look at some nearby points, which we'll highlight. And first, we can ask ourselves, is this a relative maximum? Meaning, when I look at some of its nearby points, does that red point have the largest y value? And the answer would be no, because if we select this green point here, we see that it has a larger y value than my red point. So our red point here is not a relative maximum. But is it a relative minimum? The point is a relative minimum if it has the smallest y value of all points nearby. So looking at my highlighted region, does my red point here have the smallest y value? And the answer is yes. So that's why this red point is a relative minimum. It turns out that this point is not the only relative minimum on our graph. The point here is also a relative minimum. When we compare this point with some of its nearby points, we see that this point here has the lowest y value in our highlighted region. From this example, we see that relative maximums occur at the tops of the hills in our graph, and relative minimums occur at the bottoms of valleys in our graph. You might also observe that we have relative maximums at points where our graph transitions from increasing to decreasing. Here as well, at this relative maximum, before it, our graph is increasing, after it, our graph is decreasing. So again, when our graph transitions from increasing to decreasing, we have a relative maximum. On the other hand, if we look at our relative minimums, if we look before it, our graph is decreasing. After it, our graph is increasing. At this relative minimum, before it, our graph is decreasing. After it, our graph is increasing. So we have relative minimums when our graph transitions from decreasing to increasing. Next, let's talk about absolute extrema. For absolute maximums and minimums, or global maximums and minimums, what we want to do is look at the entire graph and determine where we have the highest point and where we have the lowest point. We say that a function has an absolute maximum or a global maximum at a point a comma f of a if f of a is the largest output or y value in the entire graph. Similarly, we say that a function has an absolute minimum or a global minimum at a point a comma f of a if f of a is the smallest output or y value in the entire graph. Let's go back to our graph and see where these absolute extrema occur. For the absolute maximum, we're looking for the point on the graph with the largest y value. If we want the largest y value, we're looking for the highest point on the graph, and that would be this endpoint on the left here. This point is our absolute maximum or our global maximum. To find the absolute minimum of our function, we want to look for the point with the smallest y value. And to find the smallest y value, we want to look for the lowest point on our graph. So in our entire graph, the lowest point is this point right here. So this point is not only a relative minimum, but it's also our absolute minimum. Before we close out our video, let's look at one last example. In this example, we're given the graph of the function f, and we want to find its relative extrema and absolute extrema. Remember that relative maximums occur at the tops of hills, or where your graph transitions from increasing to decreasing. In this function, it occurs at the point 0, 1. Before that point, our function is increasing, and after that point, our function is decreasing. So our relative max here is 0, 1. For relative minimums, we're looking at the bottoms of the valleys in our graph, or when our graph transitions from decreasing to increasing. In this example, there are two relative minimums, one at -2, -3, and the other at 3, -2. At these points before the graph is decreasing and after the graph is increasing. Decreasing before, increasing after. So our two relative minimums here are -2, -3, and 3, -2. If we want to find the absolute maximum of our function, we want to look at the highest point in our entire graph. And that point would be 5, 5 here. So our absolute max is 5, 5. The absolute minimum is the lowest point on our graph, and that would be the point here at -2, -3. So in this video, we've learned about relative extrema or local extrema, and we also learned about absolute extrema or global extrema. And we learned how to find them when we're given the graph of our function.